Okay, hello once again. So we'll be continuing the discussion for area or areas for enclosed by curves, okay, or area bounded by certain region enclosed by graph. So for example, number two, so we are to compute the area of the region, so enclosed by the graphs of the given equation. So we have the first one is y is equals to x squared, and the second one is y is equals to x plus 2. As we can see here, so we have a quadratic equation and a linear equation. So based on the given and quadratic equations so resembles parabola, so while linear equations so resembles a line. So the first thing in finding the area, so we need to graph. Okay, so we need to graph so the two given equations. So we'll start with the first one, so which is y is equals to x squared. So recall that this is a parabola, and then so since this is y is equals to x squared, so this is a parabola, and then this one is going upward. Okay, so y is equals to x squared, so it is positive, and therefore, so this is something that is going upward. And so since this is just a plain y is equals to x squared, so that means this is a parabola whose vertex lies at point 0, 0, or at the origin. And then the second one is y is equals to x plus 2. So we can easily graph this one so by getting the x and y intercept, so which I'll be showing later on. So let me uh, provide a graph for that. Okay, so let's graph uh, y is equals to x squared. So y is equals to x squared. So it has a vertex of 0, 0. Okay, and then it is opening upward. And next is for the line y is equals to x plus 2. Okay, so to graph this one, so we get the x-intercept and the y-intercept. So that is, we're going to substitute for when x equals to 0, so we can see that y is equals to 2. Then when y is equals to 0, so x is negative 2. Okay. So when x is equals to 0, so we substitute x to 0, so that makes it y is equals to 2. And then when y is equals to 2, we transpose the x plus, or we transpose the positive 2, it will become a negative 2. Okay, so to graph that one, so we can start graphing the line first. Okay, so for the line, so we have the x-intercept when x is 0, y is equals to 2. And then when y is 0, x is negative 2. So these are the two intercepts. So when x is 0, y is to 2, so that's the y-intercept. Then for the uh, x-intercept, so we have a negative 2. Okay. So this will be the line. Okay, so this is the line y is equals to x plus 2. Then the other one, so I'll be graphing y is equals to x squared. So it has, okay, so the vertex of 0, 0. Okay, so vertex is 0, 0. However, so this one is opening upward. So for us to draw it properly, although we can get the focus of the parabola, okay, so we can get the focus of the parabola, but then the easiest way on how to do that, on how to graph this, is just to get the point of intersection. So I'm just going to get the point of intersection of my parabola, of the parabola, as well as the line. Okay, so the point of intersection so will serve as the boundary. Okay, so in finding the area bounded by the line and the parabola. So in getting the point of intersection, so we just simply equate. Okay, so we just simply equate the two equations. So when y is equals to x squared, so the other one is y is equals to x plus 2. So from there, so since y is equals to x squared and y is equals to x plus 2, so we have values for y, so we can equate the two. So therefore, it follows that x squared is equals to x plus 2. So this time, we just need to solve the quadratic equation. So to find the values of x, so x squared, so minus x, then plus 2 will be negative 2 is equals to 0. So I'm going to factor this out. So x and x, so the factor of negative 2, so will be a negative 2 and a positive 2. Okay, so a negative 2, or is it a negative 2 and a positive 1. So that makes it a negative 2x plus x, that is negative x. So we'll be able to get the middle term. And negative 2 times positive 1, so that makes it a negative 2. So therefore, so our first point, so x sub 1, so x minus 2, so that would be x minus 2 is equals to 0. So therefore, x, or our first x, or x sub 1 will be positive 2. The other one is x plus 1 is equals to 0. So therefore, our x sub 2 will be negative 1. So since this is a point of intersection, so this should be a pair, or an ordered pair. So to get that, so we can either of the two. Okay, so I can use this one, the x plus 2. So let's say when to get the value of y sub 1, so that will be x sub 1 plus 2. So our x sub 1 is 2. Okay, so x sub 1 is 2 plus 2, so that makes it 4. So that makes our y sub 1. And then for y sub 2, so we'll have x sub 2 plus 2. So x sub 2 is negative 1 plus 2, so positive 1. So thus, we now have the 2 points of intersection. So that is 2 and 4. The other one is negative 1 and a positive 1. Okay, so 2, 4. So that is 1 and 2. This is 0, 1, 2, 3. Then we'll have 1, 2, 3, 4. So we have the 2 and 4. So this is 2 and this is 4. So this is the point of intersection, 2 and 4. The other one is negative 1 and 1. So this is the negative 1, negative 2, negative 3. So negative 1 and a positive 1. So this is a negative 1 and a positive 1. So negative 1 and a positive 1. So those are the 2 points of intersection. And now, so we can connect the dots. Okay, so this is our vertex. So from one of the intersection, and then this one is going up, and the other intersection is this. And that's forming, okay, our graph for y is equals to x squared. So we have the line and we have the line as well as that of the curve. Okay, so for the quadratic equation. So let's try to find, so this time the area, but before finding the area, so we need to decide, so what strip are we going to use? Okay, so can we use horizontal strip? So using horizontal strip, okay, so this one is okay. So we have the right side, which is in pink, and then the left-hand side of the strip is red. Okay, so that makes it possible. However, if I'm going to move the strip up to the bottom part, so which is this one, so there the problem lies. Okay, so the left and the right-hand side of the strip belongs to the same function, so which is under the pink graph. So therefore, it is not advisable to use a horizontal strip for this particular problem. So what are we going to do? So what we can do is we need a vertical strip. Okay, so we need a vertical strip. So for us to find the area of this. Okay. So for our vertical strip, so for the vertical strip, so this would be in terms of dx. And then the formula that we will be using there, so this will serve as our y upper. Okay, so y upper is the red one, and then y lower is the pink one. So y upper is the line, y lower is the parabola. Okay, so that is on how to find the area. Vertical strip is okay. So whether you're going to move on whatever would be the direction, left or right, the strip, so it never touches the same function. Okay, so it's always the upper function will always be the line, the lower function will always be the parabola. Okay, so now so we compute, so using our formula, that the area so area is equal to the y upper, okay, so minus y lower. Since this is a vertical strip, so that will be dx. So if that is dx, so this should be the x sub 1 to x sub 2. Or we have to take a look at the given. Okay. So that is from A to B. So our area here, so since this is dx, okay, the boundary that we will be going to get, so would be this one. Okay, so this is this area. Okay, so this area so starts from -1 up to +2. Okay, so from -1 to +2. So that will be from -1 to +2. And then our y upper is y is equals to x plus 2. X plus 2. Then our y lower is the parabola, which is x squared. So minus x squared dx. Okay, so to get the area, so we just simply find the integral So integral of x will be x squared all over 2. Then 2 is plus 2x. Then x squared will be x cubed all over 3. And we evaluate it from -1 to +2. So for the upper boundary, so we have, we'll start with 2. So 2 squared over 2, then plus 2 times 2 minus 2 cubed over 3. And minus it with -1 square all over 2 plus 2 times -1, then minus -1 cubed all over 3. So this makes it 2 squared is 4. 4 divides 2 is 2. And 2 plus 2, or 2 times 2, it's 4. And then minus, so 2 raised to 3, that will be 2, 4, 8. So 8 all over 3. And the other one, so we have -1 raised to 2, it's +1, so 1/2. Then minus 2. And then a negative, so -1 raised to 3, it's a -1. So that makes it +1/3. Okay, so 2 squared is 4. Okay, so 2 squared is 4, divides 2, it's 2. So 2 times 2, it's 4. -8 over 3, so minus -1 squared is 1/2. So 2 times -1 is -2. So minus -1 raised to 3 is -1 times negative, it's +1 all over 3. And then the next thing that we can do is, so we can get the LCD, so that will be 3. So 3 times 2, it's 6. And plus 3 times 4, it's 12. Minus, this is just 8. And minus, so this time, so we have 2 and 3, so the LCD will be 6. So 6 divides 2, it's 3 times 1, that is 3. Minus 6 times 2, it's 18. Or it's 12. 6 times 2, it's 12. And then 6 divides 2, or 3, it's 2. So plus 2. So 3 times 2, it's 6. 3 times 4, it's 12, minus 8. So minus 6 divides 3, or 6 divides 2, it's 3. Then 6 times 2, it's -12. Then 6 divides 3, that will be 2. So that makes it, so 6 plus 12 is 18. And then minus 8, that will be 10 all over 3. Minus, so 3 plus 2 is 5. 5 minus 12, it's -7 over 6. So that's making it 10 over 3 plus 7 over 6. And then the LCD is 6, so 6 divides 3, it's 2, so 20 plus 7. So making it 27 over 6. So we can find the least common multiple of these, okay, or simplify this lowest term. So by 3, so 27 divides 3 is 9, then 6 divides 3, it's 2. So therefore, so this would be our area. So area is 9 over 2 square units. Okay, so area is 9 all over 2 square units. So let's proceed with the third example. The third example, so we are given or compute the area of the region enclosed by the graphs of the given equations. So we have y is equals to x squared. So similar with the previous parabola. But the next one, so we have y is equals to -x squared plus 4x plus 6. Okay. In answering this one, so we need to find the vertex. So the vertex for the first one is 0, 0. Okay, so this is going upward. Okay. And then for the second one, it appears that this is going downward because of the negative. Right. But then let's try to see. So what will be the vertex? The vertex of that is not 0, 0. Okay. So let's try to transform the second equation into the standard form of a parabola. Okay, so to do that, so we can use some completing of the square. I'll do it here. Let's say y is equals to negative x squared plus 4x plus 6. So I want to make this one positive. Okay, so I'll be moving out the negative, so that makes it positive x squared, so minus 4x, and then minus 6. And then this is the one that I'm going to perform, completing the square. So in performing completing the square, so we take the middle term. Okay, so half of the middle term, so which is negative 4, and then square it. So half of negative 4 is negative 2, then square it would be positive 4. So that is what we are going to add there. So y then will be equal to negative, so x squared minus 4x. I'm going to add 4x, or sorry, add 4, and then minus 4, then minus 6. So this is what I added and subtracted, plus 4 minus 4. That would still be 0. So that's, I did not change anything. But I made the x squared minus 4x the perfect square. So that one, so will become, I'm going to factor out the x squared minus 4x plus 4. Okay, but before doing that, so this would make it negative. So x squared minus 4x plus 4. And then negative 4 and negative 6, that would make it a negative 10. And then I'm just going to distribute the negative. This will become negative x squared minus 4x plus 4. And then the negative times negative 10, that would be plus 10. Okay. So negative x squared minus 4x plus 4. And then the other one would be plus 10. And then from here, so I'll transpose the positive 10, so that will make it y minus 10 is equal to negative. And then since this is a perfect square, so that is actually an x minus 2 square. Right? So x minus 2 squared, that will be x squared minus 4x plus 4. And from here, so we can say that the vertex, so that will be, so the vertex can be taken here and there. So for the x, that is x minus 2 is equals to 0. So that makes x to be equal to the vertex will be 2, and then y minus 10, so will be 10. So the vertex will be 2, 10. And then for this one, so since this is x minus 0, okay, so in short, that will be 0. And then for y, that will be 0 as well. And since this is negative, okay, so that makes this one downward. Okay. So this is opening downward, while the other one, it's opening upward. So let's graph this one. I'll what's the vertex? 2 and 10. So it's the first quadrant. Okay, so I'll do it here. Okay, so this is 0, 1, or it's 2, 10. So I'll make it by 2. So 2, 4, 6, 8, 10. So 2, 4, 6, 8, 10, 12. Okay, Uh, so I'll be using the red for y is equals to x squared. Okay. So this would be that vertex. So 0, 0. Then for the other, so which is 2, 10. So this is positive 2 for x and then 10 for y. So this is the second vertex, 2, 10. First is 0, 0. But again, so you can actually graph again the parabola. So using the focus and the endpoint for the latus rectum. But then those those points won't be used. Okay, so in solving the area bounded by the curve, so instead of getting those points, so I'll just be getting the points of intersection because those are more useful as compared to the okay, so as compared to getting the focus. So I'll start with the points of intersection. So we have two graphs, that is y is equals to x squared, and the other one is y is equals to negative x squared, so plus 4x plus 6. So y is x squared, the other is y is equals to negative x squared plus 4x plus 6. So we can equate y. So that would make it x squared is equals to negative x squared plus 4x plus 6. And thus, I can transpose everything. So x squared, so plus x squared minus 4x minus 6 equals to 0. So x squared and x squared, that will be 2x squared, then minus 4x minus 6 equals to 0. However, so since the numerical coefficient of all the terms involved are even, so I can multiply everything by 1/2. So that makes it x squared minus 2x minus 3 equals to 0. So that's, and I factor this one. So to find the value of x, so factor of 3, negative 3 is 3 and 1. So I'll have negative 3 and a positive 1. So x minus 3 times x plus 1. So negative 3x plus x, it's negative 2x. Okay, so negative 3 times positive 1 will be negative 3. So that's we have x minus 1 or x minus 3 equals to 0. So therefore, our first point of intersection is positive 3. And then x plus 1 is equals to 0. So our second point of intersection will be negative 1. Then we substitute. So we get the value of y sub 1. So using y is equals to x squared. So either of the two, so you'll get the same answer. But y is equals to x squared. It's the easier one. So y then will be equal to, so or y1, so will be 3 square. So y1 then will be 9. And we have y sub 2 will be negative 1 square. So y sub 2 then will be positive 1. Okay. So 3 square is 9, negative 1 square is 1. So our points of intersection, so the first one will be a 3 and a 9. And then the other points of intersection is a negative 1 and a 1. So let's try to graph that. A 3 and a 9. So this is 3, then a 9. So this is something in between. Then the other one, so that is 3 and a 9. The other one is negative 1 and a 1. So this is negative 1 and a positive 1. It's this. So negative 1 and a 1. So we just connect. Okay, so for y is equals to x squared, so y is equals to x squared is a parabola going upward. So this is the vertex. So therefore, this is how we do it. Okay, and then I have another one. I'll just going to extend it. That's a parabola. Okay, or if you want, you can even extend this. Okay. So that it will really look like a parabola. So that's just an approximation. And the other one, so this is the vertex, and then it's going downward, it's opening downward, and then it passes the points of intersection. So these are the points of intersection. This is the first one. And so we're going to do that. And the other one is this. Okay. So that's how we draw it. Okay. So this graph is y is equals to x squared. Then that's okay. So that's the red graph. So the pink graph, that is the y is equals to negative x squared. So plus 4x plus 6. So now we decide so whether we're going to use a vertical strip or a horizontal strip. So again, the horizontal strip is not possible to use because, okay, so if I'm going to write or draw a horizontal strip there, so the left and right of the strip so touches the pink curve. Okay. So it won't be possible to use that one. But then if I'm going to use a vertical strip, so wherever you're going to move the vertical strip, so the upper portion always touches the pink curve. Okay. So our y upper will be this one. Okay. And our y lower will be this one. And then of course we'll have the dx. So how are we going to get the boundary? So the boundary then will be here. So that's the dx. So we always get the boundary on the point of intersection. So since this is dx, we just get the x coordinate of the ordered pair. So what are those? So that will be from -1 to +3. Okay, so this is the -1, then this is +3. So that will be our boundary then. So from -1 to +3. So writing our formula, so that is from A to B is y upper minus y lower dx. So our A is from -1 to +3. Y upper, so it's the pink curve. Okay, so y upper, am I correct? So y upper is the pink curve, so which is -x squared plus 4x plus 6. -x squared plus 4x plus 6. And then our y lower, so minus x squared. So that makes it from -1 to +3, so -2x squared, positive 4x, and then plus 6 dx. And then so we integrate, so -2, so multiply it with x cubed over 3, and plus 4, so x squared all over 2 plus 6x. That is from -1 to +3. -2 x cubed over 3 plus 4 x squared over 2 plus and from -1 to +3. So we substitute the upper boundary, so which is 3, so that makes it -2/3, then 3 raised to 3 plus 2 times 3 raised to 2 plus 6 times 3. Then minus -2/3, and -1 raised to 3 plus 2 times -1 raised to 2 plus 6 times -1. And okay, so we substituted the upper boundary, so which is 3, then the lower boundary, so which is negative 1. So let's try to simplify this one or evaluate this one. So 3 raised to 3, that's 27, times 2, that is 54 over 3. Then we have 3 squared, which is 9 times 2, that's 18. And 6 times 3 is 18. Minus negative 1 raised to 3 is negative 1 times negative 2/3. That makes it positive 2/3. And then negative 1 squared is positive 1 times 2. That makes it positive 2. And 6 times negative 1, that makes it negative 6. And then we combine the for the upper boundary, so minus the lower boundary. So that makes it equal to the negative 54 over 3. And 18 and 18 will be 36. And then, so we subtract, so negative times 2/3, negative 2/3. Then 2 minus 6 is negative 4. But then we multiply the negative, so that makes it positive 4. So we combine fractions. So that would be negative 54 minus 2, that's negative 56 over 3. And 36 plus 4, that makes it 40. So LCD will be 3. So that makes it negative 56. 3 times 40 is 120. And therefore, negative 56 plus 120 over 3, that makes it 64 over 3. So 64 over 3 square units will be the area. Okay, so bounded by the two curves. Okay, so we'll proceed with another example. So this will be the last example. So this time around, so it involves a trigo function. Okay, so we are going to compute the area of the region, so enclosed by the graphs of the given equations. So the first one is y is equals to cosine x, the second is y is equals to sine x, and x is equal to 0. So we need to graph these given functions. So the graph of cosine x and the graph of sine x. Although we can do different techniques on how to graph this, but the simplest one would be the elementary method. So in such a way that we're going to substitute a value for x so as to get the value of y. But then take note that for the values of x, so if it will be in region, okay, so if you're going to evaluate that one in your calculator, so it should be in region mode. And then so there are two curves and one line. So we have the x is equals to 0 line. The x is equals to 0 line is actually the y-axis. Okay. So the area that we are talking about here would be the area bounded by the y-axis as well as that of the sine and the cosine functions. So we may need to graph first so as to determine the area, okay, so bounded by the curve. So it's very important to graph because that is where we can see, okay, so what's the enclosed area. So unless we can properly graph it, so it will be very difficult for us to find the area, particularly to find the boundary that we're going to use. So in finding the area enclosed by the curve. Okay, so we'll label the graph. So for the x-axis, so we can use it in radian. So we could have pi all over 4. Okay, or that is 45 degrees. Then we have pi over 2. So 1/4, 1/2, then 3/4. So 3/4 or 3 pi over 4. Or sorry, 3 pi, that should be 4. Okay, so 3 pi over 4. Okay. And lastly, we have pi afterwards. Okay, so 3 pi all over 4 and then pi. And if we want to extend, so we can increase that further. So by adding 1 plus 1/4, that makes it 5 over 4 or 5 pi all over 4. And then, so we could have 1 plus 1/2, that is 3 pi all over 2. Okay, so that's an incorrect one. It should be 3 pi all over 2. Then we have 7 pi all over 4. And then we have the 2 pi. Okay, so that will be corrected later on. That should be 3 pi all over 2. And then for the y-axis, so since sine and cosine functions, so usually it has a range from 0 to 1. Okay, so for the y-axis, so we'll be labeling it in terms of positive 1 and a negative 1 below. Because that's the maximum value that we can get for sine and cosine. So which is 1. Right? Cosine 0 is 1. Cosine 90 is 0. So, but for sine, it's the other way around. So sine 0 is 0, then sine 90, it's 1. So we can start with y is equals to cosine x. So as I've mentioned, so we can use the elementary method. So in finding the values of y for every values of x. So I'll start with pi over 4, pi all over 2, 3 pi all over 4, then pi. Then we have 5 pi all over 4, and okay, so up to this part, I haven't corrected the 3 pi all over 4. That should be 3 pi all over 2. Okay, so I forgot the 0. So we just substitute. Okay, so the value of x, okay, so to our given equation, y is equals to cosine x. So you can use your calculator or so to evaluate this one. But if you're going to use your calculator, so you must be in radian mode. Or if you don't want to change it, so you change the angle, gain degrees. But remember, cosine 0 is 1. Cosine 90 is 0. So it follows that cosine pi is negative 1. Cosine 3 pi all over 2 should be 0. And then, okay, so that's the time that I corrected the 3 pi all over 2. That is 0. And cosine 2 pi, that makes it positive 1. And then for the pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi all over 4. So we can use the calculator. Those are 45 degrees, 135 degrees, a 225 degrees, and a 315 degrees. So you can use your calculator to evaluate that. Okay, so cosine 45 degrees is 1 over square root of 2, or that's equivalent to square root of 2 all over 2. Okay, so it's square root of 2 all over 2. So 3 pi all over 4. So it's under the second quadrant. So that makes it a negative. Okay, so negative square root of 2 all over 2. So in this case, we are plotting when x is 0, so y is 1. And, okay, so all the values of zeros and ones are the one that were graphed. But then, okay, so pi all over 4, that's square root of 2 over 2. And then it's negative for 3 pi all over 4. And then it's negative as well. Okay, so for 5 pi all over 4, and so on. Okay, so that's how cosine function looks like. Okay, so it's a sinusoidal graph. You can notice there. Okay, so there. So we completed the table. So you can use your calculator on doing that. You can even actually use the table function of your calculator to do that. So the next one is the sine function. So sine function, its graph is the same as cosine. Okay? So it's a sinusoidal. However, there's just a difference on where will it start. You get cosine 0, or sine 0 it's 0, it's not 1. Okay? So again, so we can use our calculator to evaluate those values of x. So sine of 0 is 0, sine of pi all over 2 or 90 degrees is 1. Sine pi or 180 degrees is 0. Sine 3 pi all over 2, that is sine 270 degrees, which is negative 1. And sine 2 pi is 0 as well. And then our pi over 4 is the square root of 2 over 2. 3 pi over 4 is the same, square root of 2 over 2. So 5 pi all over 4 and 7 pi all over 4, those are the negative square root of 2 all over 2. So again, so you can use your calculator in finding the values of, or the value of y, so for different values of x. So if you're familiar on using the table function in your calculator, that would be possible as well. So you just need to enter the function, then you'll start from 0 to 360 degrees, then with an interval of 45 degrees. So you'll be able to graph on how
sine function looks like. Okay, so that's how the graph will look like then. So we're just going to connect the dots, and we'll have the pink function, okay, or the pink graph, so which would represent the sine function. So the red one correspond to the cosine function y is equals to cosine x, and then the pink one will correspond to our sine function, so y is equals to sine x. So now we are to find the area, okay, so enclosed by the curve together with that of the y-axis. Okay, so that's the y-axis, the orange one. So y-axis corresponds to x is equals to 0 axis. So therefore, the area that we will be getting there, so that would be the enclosed area between x equals to 0, y is equals to cosine x, and y is equals to sine x. And then, so to find that area, okay, so that's the area at the right side of x equals to 0, the bottom part of y is equals to cosine x, and then the upper part of y is equals to sine x. So that's the area that we will be finding. Okay, so what's that? What is that approximate area? So we decide so whether we're going to use a vertical strip or a horizontal strip. But then again, although we can use horizontal strip there, but we need to divide the area into two areas. Okay? The first area would be the area bounded by the orange and the red. The second area is the orange and the pink. But that will be a tedious work. So the easiest one or the easier one will be to use a vertical strip. Okay? Because if you're going to move the vertical strip, so from the rightmost part until the intersection of the red and pink graph, so to that of the left hand side until it reaches the orange graph, uh, the upper limit and the lower limit of the strip, or the upper end and the lower end of the strip, so touches different functions. So therefore, since this is a vertical strip, so we're going to consider the x interval. So that is 0 until the intersection of the cosine function and the y function, so which is at pi all over 4. Okay, so as you can see, even on our table, that at pi 4 or pi over 4, so y is both square root of 2 all over 2, both positive. So therefore, they intersect at that particular point. So the point of intersection then will be pi all over 4. So we can see it on the graph, but if we want, we can actually compute it. Okay, so what would be the point of intersection between y is equals to cosine x and y is equals to sine x? And that can be done by equating the two. So that makes it sine x equals to cosine x. And I'm going to divide both sides of the equation by cosine x and cosine x. So that makes it equivalent to sine over cosine x is tangent x. Then cosine x over cosine x, that is 1. And so we get the value of x. X is inverse tangent of 1. Inverse tangent of 1 is 45 degrees, or pi all over 4. So we can convert the degrees into a radian. So by multiplying pi all over 180 degrees, so that makes it 45 over 180, that is 1/4. Or that makes it pi all over 4. Okay, so now we have our boundary. So we are going to evaluate the area, okay, so from 0 to pi all over 4. And since this is a vertical strip, so we will be using y upper minus y lower. And let's try to see how this works out. Okay, so that's a point of intersection that is from pi all over 4 for the x, and then the y portion will be square root of 2 all over 2. But then since this is dx, since the strip that we're using involves dx, then our interval should be coming from the x values. Okay? Or that is the 0 to pi all over 4. Okay, so our formula for area will be the lower boundary to upper boundary, so y upper minus y lower. So look at the strip. So that's from 0 to pi all over 4, y upper. So the strip touches the upper end of the strip touches the red graph, so which is the cosine. And then the lower portion of the strip touches the sine function. So therefore, that is our working equation or working formula. So then we find the integral of cosine x, so which is positive sine x minus integral of sine x is negative cosine x. Then we evaluate it from 0 to pi all over 4. So that makes it sine x, negative and negative would be positive cosine x from 0 to pi all over 4. So we substitute the upper limit, so sine 45 sine pi over 4 plus cosine pi over 4. And then we minus the lower limit, so which is sine 0 plus cosine 0. And sine 0 is 0, cosine 0 is 1. Sine pi all over 4, that is square root of 2 all over 2. So which is the same. So whether that's cosine or sine. Square root of 2 over 2 plus square root of 2 over 2, then minus 1. And then square root of 2 all over 2 plus square root of 2 all over 2, that is the same as 1 half plus 1 half, which is 1. Then multiply it with square root of 2, minus 1. And that will be the area then. Okay, so the square root of 2 minus 1 square units would be the area bounded by the cosine, sine, as well as the x-axis. And that is all about area. Okay, so involving curves in a rectangular coordinate or a rectangular form. So these are only 4 examples. So there are examples which are still available on our module. So those are different examples that you can take a look at if you are still having difficulty about this topic. However, you need to practice. Okay? So you need to practice. Everything lies on the graph because you can see that the formula will be derived so using the graph. And practice, of course, definitely, so will be very useful. Okay? So you need to do it on your own. So otherwise, it will be very difficult for you. So to solve problems, okay, so involving area. Okay. So the succeeding topics are a bit complex. So next one will cover the area of polar curves. Okay. So we need to recall on how to graph polar curves. And then lastly is we're going to find the volumes of solids of revolution. So this time this is two-dimensional. So when we come to volume, so we are going to rotate. Okay, so we're going to rotate those areas or those enclosed areas to form a solid figure. And that will be all. Good day.